Alrighty. With all that, at this point, we have our main program, and I'm going to turn it over to Brendan to introduce our guest speaker for this evening. So, Brendan, if you are ready, please go ahead.
Thank you, Andrew, and the group. Oh, wait, I thought I was on a repeater. So Ben Mills has, over the last couple of years, have become a very good close friend of mine, so I'm happy that Ben is back to talk more about DMR. Ben is a volunteer advanced EMT in the Sterling Rescue Organization. He's an extra class ham radio, call sign November 4, Charlie Victor. His ham radio nickname is Crazy Virginian. And Ben is one of the parties responsible in a small group of people that are helping the Marine Corps Marathon transition from D-Star data to ARDN, Amateur Radio Emergency Data Network technology use for the back-end medical database stuff at the Marine Corps Marathon. So he is very technically savvy. He is a former RF engineer working with Motorola on the Moto Turbo stuff, DMR, and he still is an RF engineer, no longer at Motorola, somewhere a little more closer now into the Fairfax area. So without further ado, it is my pleasure to introduce Mr. Ben Mills. Ben, batter up.
Thanks, Brendan. Hi, everyone. Brendan, can you hear me all right?
Absolutely.
Perfect. Okay, thanks for the introduction, and nice to see about 70 of us online tonight. What a great turnout for a virtual ham meeting. Thanks again for having me. I met many of you VWS functions in the past, including February of 2018. I came out and Brendan asked me to do a conversation about DMR, and we had a really great turnout with lots of excited faces and good questions following that. So what I've done is I've updated the slides and discussion points to kind of tailor it to a blend of folks who have heard of DMR and maybe never heard of it or have used it and are looking for some more information about it. So as Brendan mentioned, I work professionally with DMR systems and also work with a group with Andrew and a few others around this area who have a DMR system consisting of several individual repeaters, Herndon, Tyson's Corner, Arlington, and Vienna. So we really welcome anyone to join the repeater system. The call sign on those are N3QEM, which is Steve. And we have some pretty great resources between that system, the DMR Virginia group, and there's a couple of other individual repeaters in the area that individuals have put up and connected to some of the systems that we'll talk about tonight. So I have three pages of video feeds here, which is pretty cool. Show of hands, who's talked on a DMR radio before, made a QSO with DMR. Brendan's got 2 hands up, radio in each hand, okay. And how many people have never heard of DMR before and interested in learning some more, something new? Perfect. Well, I gave this presentation to back in June to the Northern Virginia FM Association, and had lots of good turnout there. And then the following week, I gave it to the QCWA. So there's just a broad interest in DMR worldwide and globally, and looking forward to bringing it back to VWS tonight. So an introduction to digital mobile radio. So the first thing that comes up is what's the difference in DMR? A lot of people ask, what's the difference in DMR, D-Star, ESU System Fusion, P25 versus FM? So this is digital voice. The difference the difference being that your voice is digitized and sent as ones and zeros over the air instead of an analog signal. When we speak into our DMR radio, the microphone audio is actually digitized by an analog to digital converter and treated as a stream of bits after that. The vocoder is the tool that does that, and it provides the compression and forward error correction, which is built in right from the beginning. It's optimized for human voice and breaks our voice our continuous stream of audio into uniform length packets. So in addition to the payload information, header and footer are tacked on the beginning and end, just like any IP traffic or most digital data. And then this is passed to the modulator and onto the RF section of the antenna. So here's a picture, an image borrowed from QST, kind of describing our audio analog signal digitized, vocoded, and framed, and then goes out to the modulator and the antenna. So once we hit the modulator and go out to the antenna, it's UHF radio, VHF 900 megahertz, and even 220 megahertz. Those are the main bands that you'll find DMR. It's not well optimized for the HF channel, and at higher frequencies, there's a lot more multipath and fading, which you'll see in a little bit how it can affect DMR more than some modes. So what is DMR? DMR is an open and published standard, unlike some computer standards and IP standards that are closed and you have to pay a lot of money to get access to. You can go online and view all the sections of the DMR standard, which is developed by the ETSI European group. This is the same group that came up and produces and manages Tetra, which is the P25 equivalent overseas, used in many commercial radio systems and public safety. So there's 3 tiers of DMR. DMR Tier 1 is the lowest. That's actually unlicensed digital radio. In some countries, they actually require all radio to be digitized. One of the things that happens either overtly or embedded in the stream without the user knowing is the information about the radio is actually encoded into the bit stream. So the serial number, for example, in some countries, radio is a lot more restricted than we have here. So, for example, by going with even a digital basic conventional radio, if I buy a radio from the place that I buy it, they might record the serial number and map it to my individual. So if I am doing bad things with my radio, monitoring and demodulating and decoding the bit stream, you could find out who's actually talking, and the government could map it back. Anyway, that's overseas. They call it DPMR 446, and it occurs right on the 446 megahertz band. So we don't do that here. It's very equivalent. It's similarly equivalent to our FRS band. Licensed conventional radio systems. This is Tier 2. This is where most of what we're doing with DMR operates. Operates from conventional. It's a conventional radio system. In the same way, repeaters are allowed. With the digital signaling available, there's all sorts of value add things that can be added, that can be put in there as well. So, for example, Motorola has taken that and added some things to it, like text messaging. Actually, text messaging is part of the DMR standard for Tier 2, but Motorola has added some other light trunking, for example, to it, or other things. Trunk radio systems are Tier 3, and we don't use those in amateur very often, and it's a bit of a cost to get into the hardware and controllers for it. It's not vendor specific. So when I mentioned a Motorola radio, the same thing, anyone can make a radio that complies with the DMR standards. And the manufacturers have agreed to conform to agreements beyond the standard, including one thing that people have heard a lot about is the AMBE +2 vocoder. So it's a proprietary vocoder, which is one of the reasons digital radios are a little bit more expensive, despite the DSP and other hardware additions. There's with every vocoder that's sold, there's a license handed off to a company who generated the vocoder, and they put a lot of research into designing it and optimizing it, as I mentioned, for human voice, for narrow band voice range of audio. It has noise canceling and things like that that the hardware chips can do. And but it's important to know that's not actually part of the standard. It's just something that's been agreed upon by the DMR Association members. A little bit more about the common air interface. So we'll talk about time slot TDMA tonight, occupied bandwidth, modulation type, and as I mentioned, 30 megahertz to 1 gigahertz. In the ham radio world, we see that on 2 meters, 440, 220, and 900 megahertz. All right, so now we'll talk a little bit about time slots and channel utilization. So if you picture in the bottom left corner, this is power energy level over time and the frequency. So we kind of are thinking this, and we're adding time dimension to what we're used to seeing in our power spectral density plots. Here we have a traditional 12.5 kilohertz system. You'll notice that this is this picture shows two 12.5 kilohertz signals. In the amateur world, and before 2013 or so, many repeaters operated in 25 kilohertz, and many of our amateur equipment still operates in 25 kilohertz or wideband FM to carry on a single voice conversation in half duplex. So as an example, in the picture, maybe a third channel might be present, which actually is twice as wide as 1 and 2, or the sum of 1 and 2 together to make a single voice channel. Narrow banding has mandated that we take up less spectrum outside of the ham band. This is so channels 1 and 2 are simultaneously FDMA, and in time, when someone keys up a repeater, it's constantly keyed up until they unkey. So what TDMA does, time division multiple access, is in addition to the FDMA, frequency division multiple access, it gives us at time slots that 12.5 kilohertz signal. So in the period in the spectrum that it takes to transmit one voice channel, we can transmit 2 voice channels. So we call this 6 1/4 equivalent efficiency, which is actually 4 times the channel capacity of a 1225 kilohertz voice channel. So what this means in the amateur world is that in a single frequency allocation, we still are spacing our repeaters for 25 kilohertz repeaters. But in a single allocation, we can have 2 simultaneous voice conversations going over the air. And the time slots are 30 milliseconds long. I might mention that again, just to talk a little, as we talk a little bit more about how it looks like what it looks like on the air, and what some of the implications are that to our equipment. All right, so the next, DMR versus analog. So as I mentioned, you can carry 2 simultaneous conversations on a repeater. The subscriber units transmit in only one of those time slots. So the subscriber unit being a portable or your mobile radio, while the repeater actually transmits in both time slots, and it provides timing to synchronize and keep those time slots from overlapping by the different subscribers. It overall improves audio performance. Digital voice retains better quality than analog as the signal decreases. So as I mentioned, instead of having your signal dropping down closer to the noise floor of the receiver, while the signal is dropping, there's enough forward error correction put in place that the vocoder helps to make up for some of that gap, and it will manifest itself as bit errors. And some people might say this sounds like the audio version of pixelation that you see on the screen on your satellite when you're on your satellite feed on a rainy day or when the leaves are blowing around. Very similar. You'll start to hear bips and boops and audio cutting in and out. So I'll play this really short clip that kind of demonstrates this woman speaking with an analog and a digital radio, and comparing a good channel and a bad channel.
First, here is what you'd hear in good signal conditions.
This is an analog voice call in good signal conditions. Now this is a digital voice call in good signal conditions.
Now, listen for what you'd hear at the edge of the coverage area.
Analog voice call in poor signal conditions. This is a digital voice call in poor signal conditions.
So obviously,
Moto Turbo digital audio.
So obviously not completely at the edge where one couldn't hear them anymore, but far enough down that the vocoder and the digitization of the voice picks up some of the loss. Some other things about DMR. Longer battery life is advertised. I've never done a side-by-side comparison, but technically the radio is only transmitting about 50% of the time because of those 2 time slots that it's actually keying the final amplifier. And unlike some modes, it actually is keying the final amplifier on and off at that rate, so that you don't provide any signal into the receiver of your repeater while the other individual's time slot is going. So, however, the DSP and the vocoder take up some power. So the DMR Association advertises 40% improvement over analog radios. Encryption is available. Again, it's a string of 1 and 0s with error correction and all the other good things that can happen with that. You can apply encryption to this voice stream, although not in ham radio. You can operate in a simplex mode, radio to radio, and repeaters are all available. And then one of the great benefits of digital digital voice, which we actually do with something, it requires digital voice to do packet-based internet connections between repeaters. So whether or not the repeater actually forwards the bit stream out of the vocoder out to the internet and other connected repeaters, or if it's digitized at the repeater audio and then sent out like Echolink or IRLP might do, or if it goes down to a receiving base station at someone's house and is digitized there and goes over the internet. Ultimately, the voice is encoded at some point before it goes over the air. So here's a comparison, a technical comparison of a couple of the different modes we talked about. So D-Star, DMR, Yaesu System Fusion, and APCO P25. DMR and Fusion and P25 use the same vocoder. So when our voice is first digitized, that bit stream, regardless of the modulation or the time slotting, can be replicated. It can be received and replicated and stay digitized in that same format and come out the other to another system. So for that reason, DMR and System Fusion radios, you'll see a lot more compatibility between those. And with D-Star, D-Star uses a different version of the vocoder. So in order for cross-mode communication, you'd have to transcode the bit stream and re-encode it for the D-Star. DMR is the only one that uses TDMA regularly, although P25 Phase 2 supports TDMA. And you can see that they have slightly different data rates. And DMR, as I mentioned, has the 12.5 kilohertz equivalent channel occupancy. So now we'll get into more of the terminology, and we'll talk a bit more about digital radio, DMR specifically. Terminology. So a lot of the naming conventions in DMR come out of the commercial radio context, and we're actually familiar with a lot more of these terms than we're aware of. PL is one very common one, actually. Private line being another name for CT/CSS tone, which is one thing we've become familiar with. Radio channels versus the difference between a radio channel and a voice path, or some of that's where it starts to become a little bit more confusing as we start to talk about digital radio, because in analog radio, when we say we're occupying a channel, we're actually occupying frequency bandwidth. However, with digital modes, when we're saying we're operating on a channel, we may actually have two people operating in the same physical channel, but we are communicating at the same time and using what we'll refer to here in a little bit as a talk group, or some people call that a personality of a set of configurations. As I mentioned, DMR programming has a little bit more of a learning curve to get on the air, and that kind of turns a lot of people off to exploring it. And I want to make sure tonight we talk through some of those things and get those questions answered, so people know how to perhaps buy a radio at a Hamfest or online. And get on the air, or borrow a radio, or buy one from a friend and get it customized exactly how they want it to be. So the main thing the one thing that's common among many manufacturers is now what we call a code plug. And I think Chirp may or may not use the same term, but a code plug can be thought of as a file that you generate on a PC and push into the radio to contain all of the channel configurations. Like for example, Chirp on our analog world, that might be looks like a table of frequencies, names we want our radio screen to show, repeater offsets, and PL or CT CSS tones, and that sort of thing. When we get into digital world, we'll talk a little bit more depth about that. So the very first thing, and this is different from that from an identifier that I mentioned built into the hardware of the radio, is the radio ID. every radio must have a unique numerical identifier, radio ID, in order to be decoded and addressed elsewhere in the system. So it's sent as part of your transmission, and as part of that header message, it's very similar to what we start a message with, KM4HRR from N4CD. That's encoded digitally, tells Brendan's radio to automatically unsquelch when he hears his ID in the to field, for example, where everybody else's radios might stay unsquelched or stay squelched and not hear the audio, not basically wake up to that transmission. So other radios actually maintain a lookup table of everyone else's radio IDs. So somebody's got to organize all of this, and there's now a group, RadioID.net, who gives out DMR IDs. There isn't really any enforcement that you have to use a DMR ID, or that it be required to access a system. That would be kind of hard to implement in ham systems that we're putting together, but it helps with coordination, and it definitely helps with finding your friend's ID without having to all exchange them before communicating. So radio IDs for individuals are set up as 8 digits in the ham radio world, and anyone with a ham license can go apply for one, and this is worldwide. I'll show you a little bit how we get onto the Radio ID website and how we apply for one. Anybody can go do it, and I suggest if you're thinking about getting into DMR, go ahead and do this. They now require you to send a scanned image of your license to show that you're a ham and that you're actually applying for it. And then they keep a database, they'll assign you an ID and keep a database of that. So then the next concept is a talk group. Talk groups is common terminology in commercial and public safety radio. These are squelch groups that are groups of users that share a time slot. So as I mentioned, the way I could address Brendan, where I might transmit out to Brendan with his radio ID, from my radio ID as part of the framed message that I program my radio to do. We can also have a talk group ID, and what happens is I would transmit out here at the bottom the 3151. If I'm on a repeater and I transmit to 3151 from my ID, anyone else can program their radio on a channel that they have set up to listen for 3151 and unsquelch on that. So that's how we have wide area conversations, or more conventionally repeater conversations, is that everyone's using 3151 as their destination ID, and their individual source ID is where they're transmitting from. So since this is part of that bit stream, it propagates the network, as we talked about networking repeaters. That propagates and will show up on the other side. So if I, in the same way that DStart might operate, I can make an addressed call to an individual over an IP-linked repeater system without having to basically everybody that's repeaters connected hear all of the conversations going on simultaneously. So this is pretty common between So we're here. We now see that in a repeater, 12.5 kilohertz repeater channel, we can have multiple talk groups going on. DStar calls them reflectors, and Fusion calls them rooms. And this is actually, the word talk group comes from some of the original use of PL or CTCSS tones, where you might have a community repeater. And this was very common. An analog repeater would share one frequency, and the taxi cab company would use PL 79.0, and the dog catcher would use 151.4, and the other community groups, taxis or ambulance or whoever needed a radio system would pay a monthly fee to the local radio shop who owned the nice mountaintop repeater, and then they'd all have their own private talk groups to use. And obviously, as we know, there can be contention if two people key up at the same time, but you can share the resource without everybody. It's based on the principle that there won't be many people trying to transmit at the very same time. So then a channel. So differently than an actual occupied bandwidth channel, we're talking about the RF transmit and receive frequencies that we need, a color code which identifies which system we're talking to. In a busy area, you might have more than one DMR system operating in the same frequency, or maybe the repeater in Philadelphia, for example, that might have the same frequency, and during tropoducting season, we hear their audio come through our receivers. Color code is kind of like a PL tone. You can choose 1 through 16 when you set up your repeater. People have to use that color code to enter the system. It's published, but it keeps you from keying up another repeater system unintentionally. You have to select which time slot you want to operate on. So time slot 1 or time slot 2 is just set in the drop down when you configure the parameters for a particular channel. The talk group you want to transmit to, and then the admit criteria. So that means do I want my radio to be polite and wait to make sure that the color code is free, or do I want to be completely impolite and say just every time I push that transmit button, I want to go out over the air, no matter the impact on others. So you can set that on a channel by channel basis. And then you can actually set things on an individual basis, like the power level, and you could have different scan groups or receive groups in place. One thing that most radios you cannot change radio channel to channel, though, is your radio ID. That's generally set in the radio. People have asked this question, hey, if I have a DMR radio for work and my radio ID is used there, can I, and they let me reprogram my radio, can I add in some ham frequencies and use that? The answer is yes, you can, provided that's allowed by your organization. But know that you can't use two different IDs. You can't use your ham ID on some channels and your work radio ID on other ones. So here's an example of a configuration page. It might be nice to sometime show like a side-by-side with chirp, where you have a very basic frequency, PL, and offset. We have a few more things to set here, and the really important ones are circled in red. So the channel name is what we like to see on the screen. You can make it look like anything you want. This is a sort of cryptic code to tell me I'm using the Vienna repeater, time slot 2, and then Virginia 3151. So Vienna tells me which repeater I am on because I don't have space to type out the entire frequency, like say I'm on a 900 machine. We don't do that as much on DMR. Time slot 2 just lets me know, although this is time slot 1, so this must be Vienna's repeater number 2 because there's a couple repeaters there. Virginia 3151 is my is the name of the group I want to talk to and the group number. So just like any radio, I need to set the frequency I'll be transmitting and receiving on. I want to use admit criteria, color code. That's a good one to set it to. And then I need my contact name. So if this was a private call to Brendan, I would change my channel name to say Brendan only. And then I put his radio ID in here as my contact name. You don't need to set a group list. It's not necessary. Color code and the repeater slot. So Brendan would have a matching channel that says Ben's ID as the contact name. And that means that only when whenever he hits that button, only my radio and squelch is provided all parameters. Otherwise on this page are the same. Here's an example from a CS800 radio, which is a mobile that I have. This one, I'll talk a little bit more about radios and how to get them in a little bit, but this is similar. This kind of looks a little bit more, Motorola uses a similar layout for theirs. I don't think I have a picture of Motorola's, they call it customer programming software. CPS, actually, I think that all of the manufacturers call it that now. Again, the channel alias is the screen name. I'm going to be using color code 1, repeater time slot 1, and then my receive and my transmit. So related to receive, I could have a receive group. I'm not going to get into that tonight because you don't need to set that when you use DMR for ham. Transmit will be my transmit frequency, which group I'm going out to, local 27500 or 3151 for Virginia, or whatever Brendan's is, which I'll show you how to look up if you want a private call just to Brendan when you push that transmit. And again, the admit criteria is your choice. So then the next piece of terminology is the zone. So the zone is a group of channels that the user defines in his own radio. So there's many radios limit this to 16, and that's kind of a legacy left over from when we had mechanical 16 position selectors to choose different crystals, or PL reads when we wanted to change channel on our radio. So, so many radios limit that to 16, but you can just, you're probably getting the idea here. You can configure your radio the same way, and yours will look nothing like Brendan's or the guy next to you. Traditionally, the zone is kind of a geographical area of operation. However, I like to set mine up so that everything on one repeater is in one zone, and then I can select the zone separately on the radio. So think about it like the channel knob and those banks that we can put in our Yaesu or Kenwood radios, where you I think you can have like 1 or 2 or 3 banks of channels. So maybe 20 channels in a bank, and then you can select which bank you want to go to. So when you're going to your vacation house at the Outer Banks, you just hit a few more buttons on the front screen of the radio, and now you're in your North Carolina zone, and then can tune around in there and choose the channel you want to talk on. Okay, so now we'll talk about repeaters. Repeaters operate very similarly to conventional analog repeaters. They receive both time slots independently, and they transmit full duty cycle on both. They provide that time reference for the subscriber radios. And talk groups can be designated. You can put filters on this. So I could set my repeater up to only allow certain group calls to be entered, or to patch any talk group that people want to key up with. They don't require internet access for local communications, but they can be networked to give you wide area, statewide, nationwide, or global. 2 currently very popular brands are Motorola and Bridgecom. Those are kind of the 2 main ones we see kind of on the market right now. You might still see Hytera equipment out there, but that's not for sale as much anymore. But there are Hytera repeaters out there. So again, you can set up you can buy a DMR repeater and set it up just like any your club's analog repeater. Put it up in place of that repeater, and now folks can use all of the functions we just talked about, except for networking wide area, and you'll be able to have 2 time slots at once. So if you look at the benefits of putting a DMR repeater up versus a new analog repeater, in half the RF bandwidth, you get twice as many conversations going at the same time. Now we'll talk about some networks, how we can connect repeaters together. So repeaters can be connected together via a network or independently. For example, if I was a company or a ham club and I had 2 repeaters in town, I can link the 2 of them together either via RF, kind of back-to-back configuration, or as or using an IP link like microwave or the conventional internet. The 2 can talk to each other, and then just like something that we're familiar with, like IRLP or Echolink. When someone keys up on one repeater, the transmission comes out simultaneous on all of the repeaters. So the very basic configuration could be 2 repeaters, and that gives me 2 time slots, and we can map them together, or they can stay independent. And if someone keys up on one of them, the transmission comes out on both of them. You can there's also another configuration which is connecting to a larger network. This is where we completely separate away from commercial uses of DMR and kind of get really into ham and some of the really cool things, value add things that hams have put together on top of DMR. So you can set your repeater up essentially as an access point, connected to Brandmeister or to a local C bridge. A C bridge might be a group of up to 15 or so repeaters together, and then it allows for off-network connections to other C bridges, and it gives the system operator a lot of control over which talk groups you want to make available. They can create new talk groups anytime they want and advertise them. They can also allow any group ID to be used as well. Brandmeister, on the other hand, provides a lot more flexibility for the user and a little bit less for the repeater owner. You can connect a repeater up to Brandmeister. You log into their website, they'll give you the connection requirements for it. You register your repeater radio ID with them, and then you can use any of their international IDs and any other repeater out there connected and allow with someone listening on those specific groups. You'll be able to talk to those people. I'll talk a little bit more about the specifics about that as I go. So as I mentioned, the repeater connects directly to the Brandmeister network. Generally, 1 time slot's reserved for local communication. The other one will let you talk on any available Brandmeister talk group. So when I put up a repeater, for example, I put up a repeater recently in Herndon, and we're going to connect it to Brandmeister. I'm going to set up time slot 2 for local communications, and I'll tie that in with a Nova local communications channel. And then time slot 1, bring your own channel. There's over 500 published groups on Brandmeister. If you if you want to use Brandmeister to connect to your friends on the Oklahoma channel instead of the Virginia one, feel free. You just set up your radio to transmit out to the to the Oklahoma channel, and then you'll be able to communicate with them, provided someone in Oklahoma is listening on the Oklahoma channel. Pretty cool sharing of voice communications and expansion that way. Don asked recently, are there more folks on DMR than 2-meter FM analog? That kind of depends on your experience and where you exactly are. I know for me, I used to travel. I used to commute from when I worked at Motorola in Columbia, Maryland. I used to drive from Reston over there, and I would listen to like everything in the DC area as I run around the Beltway. And there are often no conversations going on in the morning during drive time, which 10 years ago was like the busiest time to be on the radio was in drive time. So I would hear folks. I wouldn't hear anything. When I started getting into DMR and playing with that, a lot of times there'd be connections in from other places or Virginia kind of linked together, which was pretty cool. Another way to get on the air is with a hotspot. We're very fortunate that we have good repeater coverage in this area. However, a lot of people are interested in connecting their radios up via hotspot. It essentially creates a very small micro repeater, 250 milliwatts or so, and will cover your house, and you can talk to it with a portable. You can connect it right to Brandmeister, and it serves the same function as a repeater that's on Brandmeister. So there's a couple modes, a couple versions available, ranging in price. This OpenSpot 3 has a pretty cool feature. You can actually use it for cross-mode operations. So if you've already invested in a D-Star radio and you want to try out DMR, you can have it connect to DMR to the DMR Brandmeister server and receive on D-Star and have your audio come out on DMR into the DMR bridge, and likewise anything on the DMR bridge would come out your D-Star hotspot. So that's pretty cool. Text messaging and telemetry, you can built into the message framing. Private callers, I used the example earlier to make a direct call to Brendan instead of to a group. GPS tracking, a lot of the radios actually have GPS in them. The Anytones and some of the Motorola's have those. And actually, Brandmeister has a way that you can allow your repeater to pass that GPS traffic like APRS up to the Brandmeister server. They'll cross over the APRS network. Scanning and roaming. Scanning is going through a list of channels on the same repeater or independently, and roaming is actually cool. If you wanted to set up a roaming group, so as you move between repeaters, your radio automatically jumps on the one with the strongest signal strength, because as I mentioned, many repeaters carry the same talk groups, and you might want to listen to the same conversation as you drive around the Beltway. Talk around mode versus simplex. Similar operations operating on a repeater channel versus a designated simplex channel. There's a lot of people on DMR. As of this year, this summer, there are over 165 registered radio IDs out there. These are people who have gone out and set up an ID, which we'll show you about here in a little while. And there's a lot of repeaters up as well. There's as many as 100 in Virginia. Different ways you can get on DMR. Multiple vendors that make radios. The price is the entry point for digital radio. DMR is probably the least. You can get them for as low as $80 to $100, and a lot of them are available. They can do analog cross mode, or not cross mode, but can also be used for analog operations. So if you're looking to get your first radio, similar to many with other digital radios, you can use them back compatibly with FM. Here's a few examples. The Tytera MD380 has been wildly popular because it's only about $100. It's probably only like $80 now. The MD9600 is a popular mobile from them. Connect Systems, this is a radio that I like and I have. The CS800 is a mobile. It has a removable control head, which I think is cool for installation, and the mic plugs into the control head, which is nice as well. Anytones are very popular now, and the Anytone radio, the D868 and 878, these are actually, they're dual band. I think they might be tri-band as well. I don't know of any 1.25 meter repeaters right now, but that you can talk on simplex or put up the regions first if you'd like. And the D8578 mobile is a is a popular mobile as well, though the control head does not come off on that one. And they have a pretty interesting microphone that I'd never seen before. One other cool thing is they have Bluetooth built in. Both of the mobile and portable have options for GPS and Bluetooth. So in this configuration, you can pair it with a Bluetooth headset and put that PTT button on your steering wheel, as a virtually hands-free operation. Motorola has a number of radios, and you can find these very reasonably priced for a couple $100. However, one of the limitations of the Motorola equipment is their programming software is not free, and so if you kind of get into that ecosystem, you can invest in it once, whereas most of the other software and cables come free. Motorola doesn't. But they have some very different form factors. They have a cell phone like one, which is about 2 watts output, color display on the mobile, and everything in between. This is a cool radio. This is the RF Finder, R-Finder. It's an Android phone in the front and a radio in the back. It's really not that much thicker than a phone. And you can they're actually using the ARL repeater book here, and you can click on the repeater you want to use, and it configures the UHF radio immediately, and then you can use the side button to PTT and talk on the radio. So a little bit about how to get onto local repeater systems. There are many resources out there, and I'll show you a couple links to them as we go. DMR Virginia is probably our largest in Virginia, and they have about 15 repeaters that are linked together in a system, and so you can seamlessly drive down 95 or 81 and carry a conversation for a good while between their different repeaters. And again, since they're networked using the Virginia statewide channel, you may be able to carry that conversation as you drive through most of the state. They have one in DC around here. The Linden repeater out west on 66 near Front Royal has really great coverage as well, being a high mountaintop repeater versus a building top like many others around here. Fredericksburg is offline right now, but that fills in the center of 95 between Richmond and DC. Our neighbors in Alexandria have a repeater up at the hospital there. And then the DMR system that I help with is N3QEM, and this one's kind of more focused on the Fairfax, mostly the Fairfax area, Arlington, Loudoun County, and then definitely coverage into Maryland. This is kind of a conglomeration of the 3 repeaters that are 3 main sites that are up now. It looks like the Tyson's one actually isn't in this, and I'll show you the coverage for that in a minute. I'll share this presentation when I'm finished, and you can follow up on the links afterwards. The Herndon repeater remains a pretty strong one in this area, as you can see. Covers most of Vienna, and basically between 7 and 66, about 7 and about 66. Great coverage, portables, mobiles. Tyson's Corner is the new big UHF repeater in town, and this is actually co-located with your club's K4HTA VHF repeater, and that one is in Tyson's, and from a very high location has extremely impressive coverage on UHF. So this will help. This is tied in with the Herndon and other repeaters. So conversation as you're on the north or south end of the Beltway, as you head out toward Leesburg, you can kind of seamlessly transition between the repeaters. Installing a repeater is really not that different than what we do with conventional analog repeaters. You can see from the picture here, this is actually 2 repeaters in this three repeaters in this picture, 4 repeaters in this picture. So you have your repeater. This is a receive multi-coupler and a duplexer, and then the network gear to get it online, because this one's connected to the N3QEMC bridge. In Herndon, there's a 900 megahertz repeater up. We're looking at putting a 900 repeater up in Arlington as well, because it has good propagation in that urban area. There's also one in Vienna. And right now there's a UHF repeater in Arlington, but because this overlaps so well with the Tyson's repeater, we're looking at moving this repeater pair out to Tyson's. And then the ones that are advertised for Vienna, while you may be very excited about them because this being the Vienna club, it's kind of on the north side of Vienna, closer to the toll road, and getting down over the hill into like downtown part of Vienna. The in-building coverage isn't as good, despite it being the Vienna repeater. I would suggest don't give up and try the Herndon repeater if you have trouble with the Vienna ones. So there's a VHF one there, and we're actually about to turn on a VHF one in Herndon as well, which will help. Which will help with coverage out to the west and give you VHF access as well. And Vienna has 900 megahertz. If you're close enough to one of the 900 megahertz repeaters, it's actually really easy, a lot cheaper to get the portables. You can get the portable radios for them extremely inexpensive online, and you just have to, as you can tell, they just have much shorter coverage areas. So the repeater book and the ARL repeater book both list repeaters now that are DMR capable. And as I mentioned, some of those things about the time slots and the Talkgroup IDs, the repeater book actually carries them now. When you go on the website, you can see which time slot you can access that on. And we use Simplex. These are some of the common Simplex frequencies. And again, you do need to set up your Talkgroup and color code and time slot so that you can talk to your friends and colleagues on that. So UHF and VHF, you might find other DMR interested folks at Hamfests using this. And here's some resources for getting on the air. Again, the very basics. Get your radio ID set up. Go ahead and get that squared away a week or so before you want to get your radio on the air. Find repeaters in your area, and then configure the code plug with the very minimum amount of your radio ID, contact list of individual hams whose IDs you want to show up on your radio screen when they transmit. Assign the group to a zone so you can access it. Get to know your talk permit tone. It's the sound you hear when your radio has made a quick exchange with the repeater and identified that you're in range of the repeater and can go ahead and transmit, as opposed to a busy or access denied tone, which means you're out of range or the repeater's already in use. It may be in use if two people are having a private call and you try to key up when they're using the frequency already. And here's some links that I'll let you explore on your own. And get involved. There's a ton of stuff we can do with DMR. Nationwide and worldwide nets. We hear Virginia statewide nets now. We hear folks getting together for technical conversations. DMR technical and others folks meet for that. Emergency communications, as I mentioned. I mean, you get 2 talk paths for the space of one. If you're lucky enough to have a repeater pair, you can now put up a DMR repeater and let 2 people talk at the same time on the same frequency. Interoperability. You can put up your own hotspot or make one for your neighborhood. I talked briefly about microwave linking. So there's Brendan and myself and a few others are involved in a project around here called Nova Mesh, or ARDEN, Amateur Radio Emergency Data Network, of setting up microwave links in the ham bands. And we can actually pass the IP traffic required for DMR over the ham band and microwave, so that if the conventional networks are down, we can still link repeaters throughout the area. And here's my email address if you have any questions. So in the last 5 minutes of my presentation, I'll go through a few more things. Here's the DMR Virginia group. They have some news. They don't post that often, but this is the group that I mentioned maintains the repeater network that covers most of Virginia. I will point you to interesting on their website, the repeater list. This will show you the specifics about each of the repeaters, the frequencies, and their talk groups. I'll show you a little bit about that in a minute. Downloads section, they actually have some nice pre-built code plugs that you could get started with if you buy a new Anytone 868 or an MD380, which are popular, or one of the Motorola radios. You can actually use this as a great starting place, and they update it. You see, they just updated them in June. There's a guy down in Roanoke who does a really good job of keeping these up to date. And they actually include our local Vienna, Herndon, and Tysons and Arlington repeaters in their code plug. So you can download this code plug, put your own ID into your radio, and get on the air. This is the website radioid.net, where you'll go to register your radio ID. And as you can see, I searched Brendan here, and I can see his radio ID. So I have Brendan's call sign programmed into the contact list of my radio, so that when he transmits his, whenever the transmission has Brendan's ID in that from field, which I can't see, again, it's just part of the bit stream, his ID will show up on the screen of my radio, which is pretty cool. And again, I can use that for private calls to him. A couple of the resources I mentioned, RepeaterBook. I've searched for Virginia repeaters, DMR repeaters on here. T-MARC actually lists, this is our local repeater coordinator. They actually list DMR repeaters, and I think there were like 25 when I searched in T-MARC's area. So it's really growing. No, I don't think we're going to get to these. One of the cool things about them being networked and on the internet is that you can view, and there's links in the presentation to these pages. You can view what they call the last heard list. So when someone transmits on the air, their radio ID decodes to their user, their call sign. You can see which repeater they entered the system on. You can see what their packet loss is here. And you can see the received signal strength. So, I mean, I think this is really cool compared to analog. When someone asks, how well do you hear me? And you have to describe it to them. You can quickly log on a couple, live and actually view, check what your RSSI was and what the packet loss was of your transmission. You can help us use this to fine tune your network. If you're one of these guys who's like in -76, Reginald has a great signal. Here at this transmission, Harry, K3NF was at -100, wasn't as great. And Brendan's calling me on DMR right now, probably to tell me I have 3 minutes left in my presentation. I'd like to quickly show you a very important view, which I hope might help tie some of this together. Again, the links are in the presentation, and these are both available actually from the DMR Virginia page. This is a display that kind of conceptualizes the time slot and talk group ID and repeater frequency all in one view. So if you're interested in getting on the Alexandria repeater, you need to know the frequency to use and the offset, just like an analog repeater. And you need to know which talk groups that Alexandria has decided to make available on each time slot 1 and time slot 2. So here you see, here you can see that Alexandria has a local channel. They have the Mid-Atlantic and Southeast channels available. And they carry for example, the Tidewater and Peninsula Regional Virginia channels as well on their time slot 1. So when you want to talk on local, you need to make sure you're also using time slot 1 in your configuration. When you're wanting to transmit on the statewide channels, our local statewide channels, they've configured it so time slot 2 is for these wider area channels. So Virginia statewide, I'd recommend everybody give this a try, because this is where you're going to hear folks from all over Virginia on those repeaters I showed you previously. So they happen on time slot 2 on this network. This is the Virginia DMR system. I found this by going to DMRVA.org, looking at their DMRVA Talkgroup matrix is what they call this. And then the next one, we actually have the Northern Virginia DMR Talkgroup list on here as well. And this one shows the repeaters that I mentioned in our immediate area, be it Vienna, Herndon, or Tyson's Corner. You can see the frequencies here on the right and the time slots in which talk groups are available on which time slot. So with this matrix printed out, you could really program your radio using your computer to talk on any of the regional or local channels. Some of these very interesting wide area channels, TAC 312 and 317 are kind of general conversation channels. You'll hear people from all over on it. One night I brought up TAC 317 on my repeater, on my radio, and I was listening to it, and I heard a guy who was in Chicago talking to, it was like late at night, he was just kind of hamming it up with a guy who was a sheriff's deputy, I think in like Iowa or something. The two of them had never met except running onto this channel, both randomly just kind of listening on here. I happened to be listening in. Could have chimed in and chatted with them for a bit. Pretty interesting, and leaves a lot of opportunities to meet new folks who you might not already come across, to stay in touch with friends who you may have talked to or live out of the region. or if you move out of the region and set up your hotspot, you can communicate with folks back here in Virginia. So I guess I'm running out of time here, but one or two other talking points. It's not very easy to program a radio from the front panel, although it is possible. It really needs to be programmed via the computer with the USB cable, which is usually provided with the radios, not the Motorola ones. You buy those separately. The other thing to consider is you need your radio ID in there, and maintain your contact list if you want to see other folks' radio IDs. You'll still hear them, but you'll just see their ID show up as a number, and you wouldn't see their name and call sign show up on your screen. There's a lot more to get into. I'd be happy to answer anyone's questions. I think at this point we'll do it in the informal session afterwards. But I really appreciate you all having me on to VWS tonight to talk about DMR, and I hope that you learned something new. And be glad to follow up with anyone if they have questions or need some help getting on the air. We'd love to hear you on the air. So back to you, Andrew.
Well, thank you so much, Ben. If you're up for it, I'm sure we have a few questions. So if you're up for sticking around a little bit longer, that would be definitely appreciated. So, like I said, we can end the formal meeting here. However, if anybody has any questions for Ben, please go ahead and either post in the chat or go ahead and just open up and ask.